So remind me what you learned in lesson 1 and 2. What?
Logic.
Okay. Specifically what type of logic, Therese?
Deductive reasoning.
Okay. What did you learn, Corinne? The Euler diagram. What is it? What do we diagram in the Euler diagram? Conditional statements. What's a conditional statement?
Statement that is.
All the way in the back. Williams. William. Yeah, William. What's a conditional statement? Say it generically. If A, then B. That's right. All right. You learned in lesson 2 about a different type of statement. It has that funny looking if word in it. Right? What did you learn, Sarah? The if and only if. Do you remember what we called that? It's a, Hannah? Okay, we can write the converse of any one of those statements if it's if and only if, right? When can we use if and only if? If it is a, Therese? A definition. That's right. The if and only if is called a by what? Conditional statement. That is right. Okay? All right. Let's look at lesson 3. Actually, let's review a little bit from chapter 1 because you know what? Your test covers chapters 1 and 2. Okay. Give me some C words from chapter 1. What's one C word? Estes. What's one C word? I remember your last name, not your first. What's your first name? Jack? Is it Jack?
Jake.
Jake. Jake. What's one of the C words?
Collinear.
Collinear. Collinear. What does collinear mean? Do you remember? Jake?
It means that 2 lines are...
No, that's another word. What does it mean, Nora? Points are collinear when a line can contain them. Okay, what's another C word? Jade? Non-collinear. What's non-collinear?
No single line.
No single line can contain them. All right, everybody look at me and not your book. Here we go. Another C word. Finley, what can you think of one? Look at me, not your book. Go ahead.
Concurrent.
Concurrent. What does concurrent mean, Nathaniel? I threw you off, huh? Look at me. Finley, go ahead and tell me what concurrent means. Look at me.
Lines that intersect at the same point.
That's right. Right here. Concurrent. Okay? What's another C word?
Coplanar.
Coplanar. What's coplanar?
Plane can contain all the points.
Yes. 3 non-collinear points determine a plane. But all those points are coplanar, right? All right. That's sort of a review of all those C words. Look at lesson 3 on page 50. We're back to logic. And we're walking toward proofs. In fact, a type of a proof is taught in this lesson. This is called a direct proof. All right, look at the top of the page, this guy. I'm going to read this as a direct proof. Direct proofs all have conditional sentences. So, if he raises his spoon to his mouth, then the string is pulled. If the string is pulled, then the ladle is jerked. You following me? If the ladle is jerked, then it throws the cracker. If the cracker is thrown, it flies past the parrot. If the cracker flies past the parrot, then the parrot jumps to get the cracker. If the parrot jumps to get the cracker, then his perch tilts and upsets the seeds. Are you following me? I'm at G. If the perch tilts and upsets the seeds, then the seeds fall into the pail. If the seeds fall into the pail, the extra weight pulls the cord. If the cord is pulled, then the lighter opens and it lights the cigar. Got it? If the cigar is lit, then it sets off the rocket. If the rocket is set off, then it causes the sickle to move. If the sickle moves, then it cuts the string. If the string is cut, then the pendulum, which is attached to the napkin, is let loose. When the pendulum is let loose, then it swings back and forth, thus wiping his mouth. Isn't that convenient? Look at the theorem. Everybody look. What did I say? I said, if A, then B. I said, if B, then C. Then I said, if C, then D. If D, then E. And we're going to N. If E, then F. If F, then G. If G, then H. They don't skip any letters, huh? And all the way down to if M, then N. All the way down, right? This is a direct proof. And what are we trying to prove? The theorem we are trying to prove is if he does A, then N will happen. That's what we're trying to prove. If I do the first condition, if I do the first hypothesis, then the final conclusion is in fact true. That's what we're trying to prove. And he came up with, I don't know how many statements this is, but a bunch of statements to get to there. That is a direct proof. Listen to a few from Scripture. In Ephesians chapter 6, we have the armor of God. You know what it says? If you take up the whole armor of God, then you may be able to stand. Then you may stand. If you may stand, then your stance will be firm. That's the armor. In Ephesians 6:13. In the Bible, lots of conditional statements, right? If you take up the whole armor of God, then you may be able to stand against the enemy. And if you may be able to stand against the enemy, then you will be secure. Your stance will be secure. All of Psalm 1 is a direct proof. Listen, if you don't walk in the counsel of the wicked and meditate on God's word, then you'll be like a tree planted by streams of water. If you're a tree planted by streams of water, then you will yield fruit in its season. If you yield fruit in its season, then your leaf will not wither. If your leaf doesn't wither, then you will prosper. All of Psalm 1 compares the wicked and the righteous. And it is as though it is a direct proof. And I could go back to the beginning. If I walk in God's counsel, then I will prosper. That's the last one. If A, then the last conclusion. That is a direct proof. A syllogism. All right, so I could write this as in a Euler diagram because this is a syllogism. Look at the definition of syllogism on page 51. it typically has fewer conditional statements. All right, so let's just look at the syllogism on page 51. It says, if A, then B, if B, then C, therefore, if A, then C. These two statements, they're called premises. They are conditional statements, right? They're the premises of your argument. It's what you're using for your argument. This is your theorem that you're trying to prove. Your theorem that you're trying to prove. It is also the conclusion. The final conclusion. I could draw this as a Euler diagram. A syllogism. So this is a syllogism. I could say if A, then B, and if B, then C, such that all of A is in B and all of B is in C. That's why I can say if I start with A, then I have C. This in a Euler diagram would be, all right, if I take up the armor of God, what may happen? I may stand. If I stand against the schemes of the devil, then I will stand firm. That is a Euler diagram. This is a direct proof. If all of my premises are in fact true, then my conclusion is true. If all of my premises are in fact true, then my conclusion is true. Okay, I want you to listen. But just because one of my premises is not true does not mean that my conclusion is not true. It doesn't mandate that the conclusion is not true. But if all my premises are, then my conclusion is true. Okay? If I do have a weak link in my premises, it is going to make me question my conclusion. Like if one of my premises, I question the truth value of it, then I'm going to question the truth value of my conclusion or what I'm trying to prove. Make sense? All right, I want you to listen to this. And I want us to draw a conclusion. Okay, so you're going to have to listen very attentively. If I go to the movie, then I'll eat popcorn. If I eat popcorn, then I'll enjoy the movie. Those two statements are called premises. What would my conclusion be? Yeah.
If I go to the movie, I'll enjoy the movie.
I will, that's right. If I go to the movie, then I'll enjoy the movie. You get it? First one to last one. All right. All accountants enjoy mathematics. So what would that be in a conditional statement? All accountants enjoy mathematics. Say it.
If you are an accountant, then you enjoy mathematics.
Correct. Here's the next premise. People who enjoy mathematics are intelligent. What would that conditional statement be?
If you enjoy mathematics, then you are intelligent.
Okay, then what's the conclusion?
If you are an accountant, then you are intelligent.
Yes, thank you. I'm an accountant. By trade. That was my major. That's why I use that one. Okay, listen to this one. I'm okay in math. All right, let's do number 5. I better be okay in math, huh? I better be good in math. All right, listen to this one. If a person is a librarian, then they read books. If a person is a friend of Diana's, then they read books. What would your conclusion be? Listen carefully. If a person is a librarian, then they read books. If a person is a friend of Diana's, then they read books. What must Diana be? A librarian. Yes, the friend must be a librarian. Okay. Let's look at an example of a direct proof. And all of our proofs, ladies and gentlemen, will be worked in this format. There are other formats, but I will only use this one. We'll have our statement and we'll have our reason. All right, so we're going to let M and N be odd numbers. And we're going to say that is given. So this will be statement 1 is going to be given in our proof, given. Our second statement will be N equals 2S plus 1 and M equals 2T plus 1. And that one too, look, that should have been 1. That statement will also be given. So in proofs, everything will be given. All right? Now, I can manipulate these equations by using algebra. All right, if I add N plus M, then I add what's on the other side. 2S plus 1 plus 2T plus 1. And that would be addition. I just added. I added the same value on each side. Then I could simplify. N plus M equals 2S plus 2T plus 2. And I would call that simplification. I can actually factor out a 2, right? I could say N plus M equals 2 times S plus T plus 1, and I would call that factoring. That's what you do in algebra, right? What is 2 times any value? Two times any value is what?
Double that value.
Is it going to be an even or an odd number? Always going to be an even number, right? Always going to be an even number. All right, so here's what I would have proven. If I add 2 odd numbers, then what? The sum is what? Even. The sum of any 2 odd numbers is an even number. That's what I've proven. And that would have just been definition of even. So, I could, let's work these on the next page. Yes, ma'am.
So how do you get to 6? Definition of even.
Definition of even from here. That's all I did was change that one.
What'd you change it to?
An even number. 2 times any value is an even number.
I'm asking, like, how did you know that was the definition of even? Like, is that a term we learned?
Because even numbers are multiples of 2. So by definition, multiples of 2. 2 times any value is going to be an even number.
So we basically.
You could just write definition of even, right? All right, let's look at some of your homework.